Welcome you to the second session of this particular topic, that is the green infrastructure solution for erosion control. We have already done the first part and we are now starting the second part. Here basically we will try to explain you different methods that we generally use for controlling this kind of erosion, and of course in different places of the world we name it in a different ways. But then when we go for actual implementation, then you need to see in your local condition what you can do, because material suggested can also be different in different place. So and then sometimes you may have to use a combination of all these methods. So basically these are the green measures for hill slope and riverbank protection, and that in general we call this as a bioengineering, because bio is related to that and then engineering we are doing with bio, so we call it as a bioengineering. And these are some typical example, not an exhaustive list, so that also we will have to be very much aware of, because there can be some other method also. Now when we talk about the erosion control, we use various mat. So erosion control mat that we can call. Now this mat can be geomat. Like geomat means when like a coir net, suppose coir we are using and we are making a mat, okay, that we are putting over the surface so that raindrop cannot directly strike and it is flowing, but then this will be gradually deteriorating, so we'll have to put vegetation along with that. When vegetation will come, it will cover the things and that will become the permanent measures. So this kind of matting we can use geosynthetic also. Geosynthetic also will of course not deteriorate with time, it has a longevity more, but then it is a synthetic material. So between this we'll have to think that whether we need a long time support or we want to get support from the vegetation. For a short time support of suppose coir net we are going, that will whether work or not. So this kind of thing. Sometimes if it is a embankment, suppose as I said that rain cuts is happening or that kind of failure, then we may have to go for concrete. Also, like there are articulated concrete block we can use where the mat is given, synthetic material mat can be given, and then we can put concrete into this, and then by pumping, slurry pumping, so that kind of things can be prepared. Of course for static maintenance we can give some green portion also in between, giving some gap but putting some hexagonal or that kind of green structures there. Then we can have palisades, okay. These are basically some barrier by bamboo also we can give this palisades, or by sometimes by strips also. If it is a small stream we can give some in the curved portion where failure is occurring, we can give some strip kind of things, like belt kind of things also people use, or pool kind of things people use. What is that? With that, the flow will not be able to attack directly the bank. At the same time, the velocity will get reduced when this kind of obstruction indicates. Now with the reduction in velocity, what will happen? If the sediment carrying water comes, the sediment will get deposited there near the bank, and that way it will protect the bank again. So we have a double benefit if it is a sediment carrying water. Porcupine structure, these are basically tripod kind of things, okay. 3 poles are there and then these are tied up like this, and then ends are being extended so that it can have a grip. Now what is the advantage? When water force try to overturn it, then even if it overturn, because all sides are equal, so it will again get a balanced position immediately. So that's the beauty of the porcupine. It is unlike creep. Creep is a elongated one. This is, if it tilted then it will fall. But here if it is tilted or if it is overturned, it will again take a balanced position. The chance of taking it away by the river is less. So this also provide a permeable water flow through that, and then speed get reduced, and that way here also this sediment deposition can be there. Then geobag and geotube. Say to protect the bank we can use, earlier suppose boulders were used, but then now boulders is not available in many places, that we call as a revetment suppose. Now for giving revetment, nowadays what is that? If the geobags are there where it is like gunny bag looks like, but then it is not gunny bag, it is a it can be of synthetic material, and then high strength, so the durability is more. So, and this can be of different size, starting from say 1 meter or 2 meter big size is also there. Now, when in the river we have sand, suppose that sand, if we insert into this and then we tie up in a special way, then these bags, if we put on the surface, then it will allow the water, to seepage water also to go out, and then when the direct current is attacking, that will not be able to erode it. So this kind of, but then toe, if it is eroded, that is again important point. Suppose you are putting some geobag, but toe is eroded, then whole things may collapse. So toe protection is also very, very important for this kind of things. And then geotube is another one. This is a big long tube. Sometimes even if embankment fail, to immediately we can make a giant tube and then we can put it, these are called mega tube kind of things. Then if we put it there and then we put sediment slurry into this, it become a bigger, just like an embankment, we can close that one immediately. Or for protection of the toe also we can use geotube kind of thing, smaller size. Similarly, stone spars or groin and this kind of revetment, as I said, that this, if stone is available there, then we can put those stones in a this is also a natural material rather. So that stone we can put extend it into the river in a particular orientation, and that we will have to put within a, sometimes a netting need to be given. Okay, so that netting if we provide, then within that all stones will be working together and that will not be washed away. But the orientation of this kind of spar is extremely important, that we can get what will be the best orientation. Of course, experience is one thing, but otherwise we can do modeling and can see for different type of flow what should be the orientation, so that this can be, so for water will be pushed away in a particular required direction. So this kind of orientation we can find out by modeling. And spacing, what should be the spacing between two such spars or a series of spars, suppose we are putting. All these things, though there are some standard, but case to case basis we can do model study. And through model study means mathematical model I am talking about, a mathematical model study. Physical model is costly, but mathematical model study we can do, and we can find out what is the spacing, what is the length of those spars, what is the orientation of those spars, and then this can be provided in a much better way. Then headwater channel treatment, as I have said, that if there is a erosion of the top by real erosion, gully formation, then how we can treat those things, different methods that we have discussed, the vegetative methods, okay, like matting and all these things, this need to be provided. And then suppose gully is forming some bunding gully control structure, we will have to put some barriers, small barriers we can put, different forms we can put it. Okay, so similarly, if we go for coir log or straw log, that we can use as a toe support, or suppose one in a slope, if we are protecting the toe by putting one log, then on the top of that we can put another one, and these need to be anchored also properly. If we do not anchor it, then there will be a problem. And along with that we need to put vegetation, like vetiver grass we can put, or different deep varieties of grass we can put, so that it has a deep root system and it can control the things eventually. Okay, so this is what we can do. Similarly, wattle or life fence or crib wall. Crib I have already shown you in my previous talk, that how the bamboo cribs are made, and it is given. Similarly, porcupine can also be given, of course, that has been explained there. And then life fence means, what is the beauty of that? Suppose in the hill slope or in a river bank slope, if we are giving some light material and making a fencing, gradually this will grow, and then the vegetation will come, and then this will protect the things in a better way. Then life fascines that we talk about, basically it can be dead stem also, and then still it can gradually grow, which mix up life stem. And then suppose we are making a roll, cylindrical roll kind of things, and on the river bank we are putting it, and then sometimes this can be used, if it is a very small stream, it can be used as a barrier also to make a steps. So this way, if we put, basically we put it on the site, and then if we protect the bank, then gradually this can grow later and can protect the things in a better way. But then here growing is rather than we tie up of our own, so that it work as a bunch and it remain there. Then similarly, vegetated reinforced soil. So what is that? Soil reinforcing means, if a slope is failing, if we can put some stem inside it, then when it is when a surface is trying to fail, then what will happen? These stems will also work as a resisting force, and then it cannot fail. So like pinning up. So it can be given like this also. Horizontally also we can put it, or in a vertical way also, or in an inclined way we can put those stems. Those stems will remain there in the slope, and then gradually the branches are, these are basically branches. So what will happen? That vegetation will come up and it will cover the things, and then it become a protection. Sometimes geotextile grid also, geogrid also we use. In a constructed slope we use geogrid for protection of, or for reinforcing the soil, or bamboo also people use for protection of the these things. So that kind of things we use, that is vegetated reinforced soil slopes that we use. Then retaining wall, gabion wall, or vegetated soft gabion can also be there. Retaining wall means that we all know that if we are making a boulder wall or a concrete wall, retaining, that can be there. But then this is what is we are talking about. Gabion means we can use a casing, and then within that casing, suppose net casing we are using, within that casing we are putting some boulders, and then it become a big block, and that block we can put on the side of the slope. And then suppose this is one block, another block we are putting like this, so that way one by one we are going in a slope direction also. And this kind of gabion structure, if it is a big gully, to clog that gully also we can put as a barrier or gully control structures, or we can on a river, if it is eroding on the side, we can put those things. So that way in different forms we can use this kind of things. Now more important point is that when we are going to actual field, then actually a particular things, we cannot say that in this point we will be applying that. It may happen that a combination of different measures we may have to use. So combined measure we will have to use, and that's why I am just giving you some practical example or practical project where this kind of measures are being used in a different forms. And then of course this methods detail you will be getting in different books. You can refer the very basic philosophy we are trying to understand what we need to do. Okay, like that, this is one successful application of some innovative vegetative measures for riverbank protection. So based on the above understanding, what we have told that this bioengineering approach was adopted for controlling bank erosion in a river. Okay, this project was done with us, along with us, one NGO, Polygon Foundation, and we provided the technical backup, technical suggestions, and on the implementation also we were there. And due to paucity of fund, there we had to use plastic grid. Okay, we had to use plastic grid to replace the geotextile or geogrid. So and that of course after that we are working also on that particular line to see that how we can improve this system. I'll be coming to that later. So first let us see that this is the project what was done, and then you can see this river was causing serious erosion on this side. And then these are the actually plastic grid. We were putting 4 net together, and this net are like this. When the water comes, it absorb the current, and then the green vegetation that is coming, this is the ipomia plant we were putting there. And then gradually this ipomia were growing and the net were covered by soil. Okay, so this was by local people made these things with the available material, different material we tried, and to anchor this net at the bottom of the river, this kind of blocks were used in some. And then on the side slope we were putting some wooden pools, so that we can tie up this net properly, so that it do not wash out. As I said, the protection of the protection measure is also extremely important, so we look into that part. And then you can see this vegetation is coming up through this net, and then gradually it is getting developed like this. And once it came to this position, this part got completely safe. Otherwise, all this area where you can see a lot of cultivations are there were eroded very badly, and people were suffering a lot. And then similarly some other varieties, local varieties, we were checking in between whether these roofs were there or not. These were intact. And then some local varieties like this we call it a stolopodmo, like that mangrove tree in the sea. This is of the kind that where you can see the stem pattern. So if it is placed in the river bank, because they are lightweight, but then it will be preventing the water to strike directly the bank. So this kind of things also we place in that area, in another area. Okay, so these are how we can solve this kind of problem. Then green solution to flood and erosion problem of hilly urban watershed. This is hilly as well as urban watershed, and basically head water erosion control we are talking about. And then urban aspect is also included, because here in India our urban things grows in a very haphazard way in the hill because of the economic region. And then if we try to protect their other aspects also, economic aspect and all these things we'll have to think about. Okay, so with that concept we started. This is the Guwahati city. It is in a digital elevation model. If we put it the satellite image over this is the Kamakhya, this is the Brahmaputra river, these are some of the wetland, these are the river network. And then we divided the whole city into 104 watersheds, and out of that we took one pilot watershed here. And in that pilot watershed, when we conducted, that was done long back, when we conducted a study, that in that period the outflow from that particular watershed was 6.031 meter cube per second. Peak discharge I am talking about, rate of flow, because this is important for erosion. So this was like that, and flooding. So this was there. But then if we cover it with vegetation in our model, then it came to 5.27. But if we remove the vegetation in our model, then it goes to 7.25. That means, what is the important point here I am trying to say is that with vegetation and without vegetation, difference can be 2 meter cube per second. In 1 second, 2 meter cube extra going means drain will be flooded. Drains are not of that big size. So that's what is the concern. Similarly, sediment, if we talk about sediment yield, that is very another important aspect. It is coming 20,000, 21,000 around in that present condition. But if we cover it with vegetation, this 21,000 can come to about 7,900, means 8,000. And then if we remove the vegetation, this is a very serious issue. It goes to 2,90,000. So that means manifold. So why it is? Because the slope and the soil type is of the kind that it creates lot of erosion. And these soils from the hills, if it comes to the plain, gully formation is there, drains get blocked, and the water do not go anywhere. It will come to the road only, causing flood. So this is what is the situation. With that understanding, we, to convince people, initially we tried to show that how the things are changing. The red patches are the habitation area in 1972, and in 2000 this is what is the situation. If I take now, that will be again different, but we are renovating many of these watershed. Government is also coming forward to renovate this kind of watershed with all these green measures. And that's why we have not placed that scenario right now, but this is what you can see. Interestingly, why people economy is important. In the plain area also it is, people are increasing, population is increasing, but in the plain area it is increasing by 3.2 times. But in the hilly area it is increasing by 10 times or 8 to 10 times. The reason is that hill area is affordable. They can encroach into it, and then because the low income group people only go there, because there is a risk of landslide, many risks are there, still people are living. It is not a very, healthy situation, but then people are living. So that's why with this, initially when some question that have you visited those areas, then we showed the photograph that this is not just we are making red and green. It is not like that. Actual situation is like that, but people are still living very pathetic condition. It is that people are still living because there is no other way out. Economy is preventing them. So what we need to do, we need to renovate these things in a way that we can have a safe living. For that, we can have different varieties of grass. Now, question is that ecological management, not only grass, bushes, forest, garden, as we discussed in our last class, that is the ecological management practice, starting with rainwater harvesting and other structural measures also. But just if I talk about grass, all these are EMP, ecological management practice. But this, if I talk about only grass, then also there are so many varieties. Now, which combination we need to take? Because some will be having different efficiency of controlling water, some will be having different efficiency of controlling sediment. So we made an experimental watershed and we conducted a pilot study, experimental study into it. That you can see that as you can see that this is one vegetated watershed where we are maintaining the vegetation, and nearby another watershed we devastated. So you can see that from the vegetated watershed, which is undisturbed, though there is a house with covered vegetation, then the clean water is coming. But then here it is disturbed watershed that is very highly sediment ridden water. Two samples were there too. So this is like this. And then we made some experimental bed also with different kind of vegetation, as you can see, and that with bare land we compared. Now increase in total volume of water is increasing several times with some severe storm. As you can see here, grass, then it is almost empty, water is not coming. We are putting the same water, then it is the here it is lot of water is coming with sediment, but then on the other side there is another variety of grass, it is less water is coming. So that way, with different kind of situation, we have different kind of situation. Water quality also get changed, chemical change is happening to the water, sediment is increasing. Now we went to the actual field, and then we convinced people that we are not coming to remove. Initially they were resisting, but then we showed that yes, we will be applying all these methods what we have told, that somewhere we will be giving retaining wall, perforated block, then creepers will be covering these things, somewhere we will be doing grass plantation, and somewhere we will be making step drain so that your breakup can be there, the current can be break, and the velocity can be break, and then it can be controlled. So this way, for each and every site we develop this kind of animations, and then we could show, we could convince people that it is for their betterment. Then we made some video songs like this, video film was made, then monographs were made, and then how much people can stay, that was also by carrying capacity we developed those things. And then rainwater harvesting, some manuals were made, some guidelines were prepared for urban drainage. With all these, we could convince the people, and finally government came forward to implement this kind of project, and you can see the result. People themselves has participated in this. Signboard is made by the people, that Paharor Matikata in Assamese language, it is Paharor Matikata Nikher, Onyothai 10,000 Taka Porjonto Jorimona. That means if you cut the hill, 10,000 rupees will be the punishment. Their income, monthly income is 2,000, 3,000, something like that at that time. So this village has come forward, so that's why it is a very heavy fine they are imposing, and with that finally this whole village was renovated with different methods. These are where the works were going on, and people started, we also advocate that they should plant in their area, they should make the plantation of their own, and that way people planted, and finally you can see this is the area where now it is even two-story building are also there, everything is there, but then inside is quite green. Everyone has planted their vegetation. We have given the vegetation, we have given the plant, they have planted, and then at the bottom there is a pond is created, and then here also if some sediments come, that will be stored here, and finally it will go out. So that way a very success pilot project has been done, and then government is coming forward to implement some more in different. This is being done by development authority, but soil conservation department is doing in different places. Like that, different departments are coming forward. Then talking about another system like matting, coir log, geobag, and pole system. So this is, we are naming as a MCGPS system that we conceptualize. There you can see that this is what is the slope, okay, fail bank, natural fail bank. And now in this bank what we can do, you see, as I said, that bamboo is there, but then it is falling because the weight is more. So the cause of failure is like that, as I explained in my previous talk. Now first we need to dress it properly. We are dressing it properly, and then after dressing with the proper angle of repose will have to be maintained. Then initial laying of coir net, that we are laying, that coir net is being placed, it is anchored on the top, and it is going into the river to some extent, and then geobags are placed, but then these geobags also sometimes are washed away. So this pole system are placed here, and with one pole 4 geobags are tied up. So it is working as a wave breaker, as well as the apron is maintained, so the bottom cannot be eroded, so this time these things cannot collapse. So this way, and after this this mat is again taken around, and it is wrapped like this. So then this is the final stage. We can see that wrapping up of the field geobag and the coir net, anchorage of the same with the coir log. So this is being done, then wrapping up of the field bag with coir mat and anchorage of the same with the coir log, same thing of course, but then we are showing in a different view. And then with that finally vegetations were given there, and with these vegetations you can see that gradually the vegetations comes, and then this is of course in the model we are showing, and it is under implementation in some place. So these vegetations are coming, and gradually this vegetation will cover things, and if the mat goes off, it doesn't matter, these things will remain intact. So this way we'll have to apply the combination. Now again there we'll have to think, suppose we are giving some vegetation, if people will have to maintain that. Now for that, if this vegetation have some value, then people will maintain. People will have to get some benefit out of that. So we discuss with our agriculture university also, and then we found that there are different type of vegetation which can grow in water and has different values. Like that you can see someone is having medicinal value, someone is having beautification value. So different has this. From here you can make cloth also, from here you can make bags also, net also. So different type of things are there which has some medicinal value as well as has other economic value. Basically we are talking about economic value. So with this kind of things, if we implement, people will take care of those, people will get benefit out of those, some society will have to be formed, and then if they work, then these things will become successful. So with this very introduction, what we can conclude that vegetation system adopted for controlling catchment erosion and riverbank erosion differs a lot. These two are different things. Then vegetation may have to be used in combination with other method as per need. So only vegetation may not survive always. So we'll have to go by combination. In case of riverbank, type of bank material, what type of material is there, height of bank, again what is the height of that bank, cause of failure plays an important role in deciding type of vegetation and its way of implementation. Okay. Then combine bioengineering approach, conceptualized and presented here as the potential of providing eco-friendly solution to erosion problem. So we'll have to go for combined effort, combined application, and then we'll get the fruit of the actual implementation. And local situation we'll have to keep in mind, and accordingly we'll have to implement. Okay. So thank you very much. Thank you all for your attention. Then in the next talk we'll be coming up with another issue, that is when it is major river flood or major river failure of bridge, etc., then what we'll have to do. So that will be coming in the next talk. Thank you very much. Thank you all.